Okay, let's start the show. Welcome to Azure Automation Tools for Azure Infrastructure. I'm really grateful that you picked this session for this time slot. What we will cover today are a couple of different automation tools that we can use to provision and manage Azure infrastructure. Some of those tools are created by Microsoft. Some of those tools are third-party tools. We will talk about Azure PowerShell and Azure CLI, the command line tools created by Microsoft. We will talk about ARM templates, also Microsoft thing. Azure Building Blocks, kind of a new thing that was created by one of the teams inside of Microsoft. And then we will cover Terraform and Ansible, created by HashiCorp and Red Hat. My name is Aleksandar Nikolic. I'm a freelance PowerShell and Azure trainer. I'm also Cloud and Data Center Management MVP and Microsoft Azure MVP. As I'm covering private and public cloud, I like to call myself hybrid MVP. I'm also one of the co-founders of PowerShellMagazine.com, the site that covers everything around PowerShell. I'm running it with a couple of my PowerShell MVP friends. So what is the goal with automation tools? What do we want to accomplish? Azure Portal is great, is getting better and better. I'm particularly satisfied with the latest changes that happened just before Ignite, and probably some of those changes will happen during Ignite. But Azure Portal is a great learning tool. You use Azure Portal to learn about new services with the helpful tooltips, some helps there. Error messages are good. If you don't know that you need to use all the, for example, casing is different for storage accounts, you will get a nice error message there. So you will be guided through the wizards how to provision your resources. But using Azure Portal is not scalable. If you need to create one VM, it's OK. But if you need to create 10 VMs, 100 VMs, you need to have some kind of automation. We need management that it's consistent, that it's scalable. And automation tools are allowing us to have automation for a complete life cycle of deployment and management of Azure infrastructure. When we talk about different infrastructure automation tools, we can kind of group them in three groups. The tools for automating configuration of the VMs, so that we can have control on how our VMs are configured from the inside. Then automating infrastructure management, all those supported resources that are needed when you work, for example, with your VMs. So networking stack, storage. And then we have also automation of application deployment and delivery. We will not cover that part. This is a focus for this session is infrastructure. And when you look at all of them, you will notice that as some kind of a glue, you will always find Azure PowerShell and Azure CLI somewhere there, right? Even if you use templates, you maybe need to deploy them using some command line tools, or if you work Azure Building Blocks, they are based on Azure CLI, for example, so those command line tools are really, really important. When we talk about configuration of our VMs, we can use a couple of different tools. For example, very popular are Ansible, Chef, and Puppet, and also Microsoft's own desired state configuration. You can fully configure your VMs. It's up to you and your team inside your organization. Do they prefer one of them or maybe a mixture? You can actually use Chef and Puppet and use, for example, DSC resources inside of your work. You can also customize your Linux VMs during initial booting using Cloud Init. That's also supported for distributions that are available in Azure Marketplace for Linux. But if you want to have customization that covers all Azure VMs, both Linux and Windows, you can use VM extensions. In particular, you can use a custom script extension. and it can run bash scripts or PowerShell scripts. Or you can use a run command feature. Run command feature is really interesting, especially for troubleshooting, because you can use run command to run scripts and target machine that it's not even available over network. That's really, really crucial because sometimes you might make some mistake or something can go really wrong with your machine. You cannot access it anymore, and then you can use run command as a solution for it. When we talk about management of infrastructure, then for building the infrastructure using code here, we can use ARM templates, Azure Building Blocks, or a Terraform. But sometimes it's needed not to use just the images that are available to you in Azure Marketplace. You will need to use probably your custom image. For that one, we can use Packer to create a custom image and then upload that to Azure and use it for provisioning VMs in Azure. There's also one interesting service that started a couple of years ago as some kind of PowerShell as a service, Azure Automation, but now it can also run Python 2 scripts, and it's probably when you see the name Azure Automation, you might think, oh, this is only for automating Azure resources. That's not true. With Azure Automation, you can actually go across all the clouds, Azure VMs, or physical machines on premises, or some other public cloud providers. How you can use them? What is the way to use all those tools? You can use them locally, using a PowerShell or some other shell, or you can use Windows subsystem for Linux, which allows you to run Linux tools on Windows 10, almost like a native environment. It's just amazing how it works. You will see that a little bit later during my demos. You can also use Azure Cloud Shell. Azure Cloud Shell is available in a portal when you click next to a bell icon, on a shell icon, or you can use a dedicated shell.azure.com link, and you will get the choice to work in a bash environment or in a PowerShell environment. Both of them actually run on the same Linux container. Why? Because PowerShell Core is now available on Linux, Windows, and Mac. So they use that so that they have one environment with some predefined, pre-configured tools, and it's up to you to pick Bash or PowerShell Core. If you're more familiar with the PowerShell, you will work in that environment. More in Bash, you will go to Bash. But you are actually using the same container underneath, and all those tools that we'll mention are actually available to you in Cloud Shell. You don't need to install Terraform. You don't need to install Ansible. You don't need to configure them. They're already pre-configured and pre-installed for you. And they are regularly updating the images to follow the new to install the new versions and stuff. The main editor, at least for me now, is Visual Studio Code. Visual Studio Code is free, it's a lightweight, and it's cross-platform. So it works both Linux and Windows and also on a Mac. All of those tools that we will mention today have extensions for Visual Studio Code, so that it can nicely, from one GUI, work with those different tools without leaving Visual Studio Code. If you prefer, if you also set up your environment to run containers, then you can run those tools in Docker containers as well. What is the benefit of that? You can just pull a proper container image, run your container, do your job, execute your task, and then close your container, and your system will be clean as before. You don't need to worry about different versioning. You don't need to worry about potential problems if you have multiple versions of the same tool installed on a machine of any of those. And you can always get the latest one that it's offered by Microsoft or some other vendors. So let's talk about Azure PowerShell. Azure PowerShell is actually Azure RM, a set of modules to use Azure Resource Manager model. You can get it from PowerShell Gallery. PowerShell Gallery is a Microsoft-owned and hosted repository for all PowerShell artifacts, scripts, modules, DSC resources, or you can download for the GitHub repo. You will download the MSI file. The difference between those two ways of installing it is that if you install it from a PowerShell gallery using install module, you will get, if you install it like one version and then later another one, you will get both versions side by side, which is really good in a way that you can kind of test. If you have a new version and suddenly your script breaks, you can load the previous version and test it again and see if it works in the previous one. Then probably a new bug is introduced in a new version. And then you can file bug on a GitHub repo, and they will then fix it. If you install it with MSI, then it will overwrite the previous version of a PowerShell, so Azure PowerShell. That's a little bit of a difference. We have also something new called AZ, which is a set of modules that can run on both Windows PowerShell and PowerShell Core. It's available to you when you work in Azure Cloud Shell environment. And it's very new. It's still version 0.20. But the way how it works is that they also change the prefix for commandlets, but they enable all the aliases. So all your scripts that worked with Azure RM will continue to work. Okay? You don't need to worry about those problems because all the new AZ commandlets are aliased to Azure RM as well, right? So there is no breaking changes there with the naming. So let me show you a demo of Azure PowerShell. So what you see here is Visual Studio Code. I've just picked a theme of PowerShell ISC so that transition is easier for people that still work with ISC. And when you install it, you need to authenticate. I already authenticated to Azure subscription. So why is it useful to use Azure PowerShell even if you want to work with templates or some other tools? You can use Azure PowerShell to find out what's available to you in your subscription. Okay? So for example, we know that we have 54 regions of Azure, I think, worldwide, but not all of them are available in every single subscription. Okay? So to know what's going on, really, you need to run get Azure RM location, and then you will get the list of only regions that are available to me when I use this particular subscription. The same thing goes for Azure Provider. And this is really interesting. This is the list that you will get for things that are already registered for you. But there is a way to say list available, and then you will get the list of registered and not registered. Why is that important? Sometimes Microsoft release a public preview of some new feature. And that public preview is not immediately, it's backed up by a provider, but that provider is not immediately registered. So you need to do that manually. So in case it's something that it's kind of a part of documentation but doesn't work immediately, you can always check if your provider is registered. If it's not, then you will register it. Right? So you'll know more what's happening. The same thing goes, for example, to check the available machine sizes in your subscription. So you will get this nice information about the number of CPUs and RAM memory and number of cores and all that really nicely from command line. There's also a way to get the list of available SKUs so that you know that some of them are available, some of them are not available in this subscription. So if that happens, then you know that you want to use standard NCS 6S v2, then you can call support and see if they can enable that one in your subscription. Okay? So those are the all things that are kind of PowerShell is really useful to find out what is your environment and how you can work with it. Let me show you here how to really quickly create a VM using PowerShell using something called Smart Default. If we look at the syntax for new Azure RM VM, you can see here that the only thing that are mandatory, the only parameters that are mandatory are credentials and name. So just specify credential and name, you can create a VM. You will not worry about anything else. Everything will be created for you. Isn't that good? For testing purposes, just perfect. So I'm already authenticated, created a credential here. And I want to show you this, that you can use a what if. You know that in PowerShell, what if is kind of a safety net. It will tell you what will happen without actually executing code. So if you run it with a what if switch, specifying just the name and credentials, it will tell you what will happen, what kind of resources will be created during the process of creation of a VM. If you want to create a Linux VM, you only need to specify image. Because by default, they think like when you work in a PowerShell, you are more like a Windows guy, so by default, they will create a Windows machine for you. If you want to create a Linux one, you will say just -image and pick one of the available images, Ubuntu, CentOS, or Debian, or something else. So let me just show you the output here, which is really awesome when you run creation with the -verbose. With -verbose parameter, you will get all this during the creation so that you know what's happening and you don't need to go to a portal to check what is the actual default VM size. What are the values for subnet, for a virtual network? What are the ports that will be open for you, okay? So you can get that information there really nicely, and at the end, you will just get confirmation that the VM is created. The only obstacle here is that this is really like for a demo purposes, when you look at the names of those resources, they are not very helpful, right? And this is not something that you will do in production, but for demo testing, when you really, really quickly need a VM to try something, this is just perfect. If you want to have a full control on the VM that you will create, this is what you need to do. You need to create all the resources that are needed. You need to create a VNet. You need to create public IP address if you want to connect to it. You need to have a network security group to allow access. You need NIC. And I will just need this a little bit later. So those are the kind of steps for that. You will need to create a resource group to put your VM there. And then you will specify credentials. In this case, I'm working with a Linux machine that I want to use only with SSH keys, not with the password. So I'm using here like a dummy password that I will not actually use because I will disable it a little bit later in the process. So I need to go through a creation of a subnet or virtual network, then a public IP, open a port, and do all that stuff. When I have a creation here, I will finally creation a VM, and I can also have a way to generate SSH keys on my machine, add them to configuration, and then send that configuration to Azure so that Azure can actually perform the action and create all those resources for me. So as you can see, there is a lot of things here. And when you pick this imperative approach to create the VMs, this is not production-ready code, right? We need to have lots of those error handling things there, right? So the beauty for me of using PowerShell is for ad hoc scripting, but you need to do something really quickly and get some information, but there is a better way to actually create those resources, especially for a complex production infrastructure environment. So let me get back to slides. The Azure CLI is a command line experience that Microsoft created in particular for Linux developers at first. And they created it because it was a cross-platform before PowerShell was cross-platform. So they needed a solution for guys that will work for a Linux environment. It's also available on Mac, Linux, and Windows. You can run it from Azure Cloud Shell, which is now just amazing because you need to do anything and you will just get it. If you're very new to Azure CLI, the best way to learn about it is to run AZ interactive command, which will put you in interactive mode with lots of help, tooltips, and IntelliSense and all that so that you can just easier learn how to work with it. because the syntax is, if you're coming from a PowerShell background, a little bit different. You can also run Azure CLI in a Docker container. You just need to run docker run slash dash IT for interactive, sometimes dash dash RM to remove it once when you are done, and then specify the image. The image is provided by Microsoft. It's Microsoft slash Azure dash CLI. And it's not that big. It comes very quickly to your machine, and you just can get the latest version that they provide there and work nicely with it. So let me show you now how the Azure CLI works with the VMs and how we can actually kind of combine the Azure CLI and PowerShell. So here for a same kind of a goal to create quickly a VM, we need first to create a resource group using AZ group create. See, the syntax is a little bit different than PowerShell, but at the same time, you can get used to it because, again, after a couple of days or maybe weeks, you will get it, and it's kind of grouped into those commands that you say AZ group, and then you have all those verbs that you can use, or those actions that you can use with the group. The really thing that I like when I work with Azure CLI to create the Linux VM is that I can automatically generate SSH keys in this command if I don't have them already. If I have them already, they will be just reused in the whole process of creating that VM. So this is the output that you will get when you run that. What's interesting for me is that when you, let me just switch to bash here. When you run azvm show to get information about the VM, what you get back is a JSON. So that JSON string now needs a new query language called JMSPot to get some information from it. So if you're coming from a PowerShell background, it's a little bit of a challenge how to get that, right? Because we are used to go through a PowerShell objects to get information. But still, you can master JMSPot as well. That's not a problem. What I want to show you here that it's, so this is the syntax, for example. It looks a little bit weird for the PowerShell guys, but it's also very effective if you are coming from a Linux background and you work those tools and you know the syntax for. But if you don't want to learn a new syntax for querying information, then you can kind of combine the Azure CLI and PowerShell. You can get the JSON string from Azure CLI, convert that to a PowerShell object, and then continue processing that through PowerShell. Isn't that cool? You just kind of combine two different tools, and you are, again, on a familiar terrain when you can just use the PowerShell knowledge, for example. So here, for example, if I want to get the NIC ID, I will run Azure CLI command, pipe that to JSON, and then continue with the PowerShell syntax, actually, to get information about the properties and things. So if I do this, and then I run to see what's in a NIC ID, I will get the NIC ID here, right? Then IP ID, and at the end, I will get the public IP address using the same methods for that. So if everything works, at the end, I should get the public IP address, right? So I created that with the Azure CLI, got the JSON file, converted into PowerShell, and got it from a PowerShell. I'm not saying that this is something that lots of people will do, but it's good to know that it's possible, because if you are more familiar with the PowerShell syntax and all that, you can always turn it in your benefit. So, to get back to slides, let's talk about ARM templates. ARM templates are a declarative way to provision Azure resources. Resources are JSON objects here. You can customize those templates using parameters. And it's very powerful. You can create really, really complex environments using it. But it's also the authoring part is a little bit harder than I would like to have. And usually how it works, you will search on a GitHub for a quick start ARM templates provided by Microsoft and a community, and try to find something that is close to your solution and then try to kind of change that a little. It's kind of a little bit hard to start from scratch writing it. But there are so many those templates available now, and probably you will find something that suits your needs. When we work with ARM templates, one of the environments is Visual Studio, but if you don't want to use Visual Studio because you think that's more for developers, Visual Studio Code can help you as well, because there is an extension for ARM tools there too that can help you with all the outline and all that stuff. So to show you how that looks like, we will not create one from scratch. I will just show you here that in ARM, I have here ARM template that it's created to provision a Linux VM. So as you can see, it's pretty long. There is lots of lines of code here. All those resources need to be defined. But to help us with that, we have this JSON outline so that we can go through all the steps that are needed there. We have sections for parameters, for variables, then for resources, and at the end for output as well, because sometimes you want to get some feedback after you created something. You want to provide a fully qualified domain names string, for example, or maybe public IP address, or even instructions how to connect to that machine. What is the username that it's needed, and IP address for a connection, for example. So every ARM template has a schema and a content, and then parameters block is not mandatory, but usually you will parameterize that because it needs to run in a kind of create in a different environments. Here, when you have it, you will get kind of a point to proper sections of your code when you can fix something or modify it if you download it from somewhere else. You can then use this template to do a provisioning from Azure PowerShell or Azure CLI, or you can actually use it also in Azure Portal and create a custom deployment in Azure Portal as well. Every time when you create something in Azure Portal, you actually get also a template for it that you can reuse later for redeployment. Another tool that I want to cover here is Azure Building Blocks. Azure Building Blocks is created by Pattern and Practices team of Microsoft, and it's based on their communication with lots of customers when they learned what people are doing and they observed and create some proven practices, some best practices defaults. So they created a new tool, AZBB. Do you like those new names for all those CLI tools? So the AZBB and a set of predefined ARM templates are there to help you to create your deployment. It's based on the Azure CLI, so that's prerequisites. You need to have Azure CLI pre-installed before you install AZBB. And how it works, you actually need to specify settings following the schema of the JSON building blocks. Then AZBB will merge those settings with defaults provided by a tool. After that, produce a set of parameter files, and then deploy those parameter files together with predefined ARM templates for you. So maybe it's not easy to follow, but as I say, picture is worth 1,000 words. So you can see here the same thing, but visually. We have defaults and settings. We use AZBB tool to get parameter files, and then during deployment, the parameter files will be combined with the templates. At the end, we will get tools. It's really interesting concept, and let me show you how easy actually it is to be used. So when, well, AZBB, let me see. So here is a very simple settings file that I want to create a virtual network. Syntax is much simpler, and the file is much simpler than ARM templates that we have seen, really, right? You define the virtual network, a subnet, and then for virtual machines, here you even have a VM count property that says how many virtual machines you want at the same time. So if you, for your demos or for your production, wants to have a couple of identical VMs, you will just change the number here, and you will get 5, 10, or more. The only thing that I don't like here is this visible password in it. So once when you have this, and you can go, for example, here to PowerShell, and you will say like AZBB, specify a resource group, a subscription ID, location when you want it, to create that, and then point to the JSON file is say just deploy. When you say that, it will create 2 parameter files, and let me show you how they look like. So this is the first one that covers the creation of a network stack. So you see how it expanded, and the other one is much, much longer. But you don't need to create any of this. Everything will be created for you by that tool. Really exciting thing for me. I don't know if they will work more on it, but at least I'm using that a lot for kind of a really quick demos that are not that simple, because it just provides me a lot of abstraction so that I don't need to think about every single detail there. And then this is the output of everything when you get all those resources that are created for you, and in the end of everything, you get your full deployment of 2 VMs in availability set, and everything is fine. You can also extend it. I mean, I'm going here about kind of a simpler examples, but you can always add some additional things using a DSC extension or a custom script extension, run some random scripts there to enable web servers and to provide the content for those web servers or configure something else. The interesting way to work with your Azure infrastructure is Terraform. Terraform templates created by HashiCorp. They allow you to define your entire Azure infrastructure. Now it's even possible to combine them with ARM templates and then use them together. It's really cool. I think that we have also a couple of sessions about that. At Ignite, one of them is actually today about Terraform and Kubernetes. So the Terraform engine also can work with multiple clouds, which is another benefit. So that if you learn how to work with Azure, you can also reuse that knowledge for something else. Or if you know how to work with some other, you can apply it to Azure. You need to have different templates, but as I said, like, knowledge is the same. You don't need to install it, or you can install it locally, you can configure it locally, but you don't have to. It's immediately available to you when you use Azure Cloud Shell. Everything is predefined, everything is just there, you just need to use it. The one that it's in the Cloud Shell is perfect for kind of a single developer, but if you have a team that works with a Terraform, then there is a better, even better solution for it. In Azure Marketplace, Azure gives us a Terraform instance based on Linux that is pre-configured for a team's work. And they use something called remote state. I will talk about it a little bit later. And this is really awesome because you just have like instance, you have an image that it's pre-configured for you with all the needed tools, and they also some additional tools are there, and you have immediately a perfect environment for your whole team of Terraform developers. We have also 2 extensions for Visual Studio Code. We have a Terraform, which is created by community members, and then we have Azure Terraform that is actually created by Microsoft. And they can help you during the authoring part in a local instance of Visual Studio Code. What is really cool is that you can work with those things locally, create a Terraform template files locally, and then you can upload them to Cloud Shell and run the deployment in Cloud Shell. Let me show you how that works. So that's for working with a Terraform, this. So let me show you first how the template looks like. So template is written in their own template language. Also, it's kind of similar to other syntaxes that we have in the JSON and the YAML, but it's more human-friendly, I think. It's just easier to read it than the JSON files. So here we have, again, the same kind of a scenario. We want to create just a Linux VM. So this is the section where we'll define everything that is needed to create a resource group, then a virtual network, a subnet, a public IPs. You see how those things are the same in every single solution that we pick, in every single tool. We have the same things. And then network security groups and all that. What is really interesting here is that when you work with Terraform, and this is a local file, if I don't want to install Terraform locally on my machine, for example, or I don't want to configure it even, I can install it just to have some benefits of running extension there, but I don't need to run it in an environment that it's just local. Yeah, I can leverage a Cloud Shell here. So to get the Cloud Shell inside of your Visual Studio Code, you need an extension called Azure Account. So how that works, you say Control-Shift-P to sign in. I already signed in. And then you say Open Bash in Cloud Shell. When you say that, just another terminal will show up in Visual Studio Code. Isn't this awesome? So this is something that runs in a Linux container somewhere in Azure Data Center. And now I'm having it here, and it looks like it's local. It's just another shell. So here, when we look, I have a bash, which is Windows subsystem for Linux. I have PowerShell, thanks to PowerShell extension, and I have Azure Cloud Shell as another one. Just beautiful. And I also set up my Visual Studio Code so that I can, with a keyboard shortcut, run any selected line from a local file in active terminal. It doesn't matter if the terminal actually exists on my machine or is it a Cloud Shell. I can send the line over a wire to a Cloud Shell and execute it there. So isn't that just magic? For me, it is. So now we are in a Bash in Cloud Shell. And let me go to my Terraform files folder when I have all the Terraform things. So I'm now there. Let me run dir. So all of those, no, dir, come on. I'm in a Linux environment. So you can see I have this Terraform underscore Azure TF file that I've just shown you that it's local, but I uploaded to a Cloud Shell. And how you upload it, you do the right click on a tab, and there is option upload to Cloud Shell, which is just beautiful. So the beauty of Terraform is that you have a couple of those steps that you need to perform. So with Terraform in it, the Terraform will check your file and see if everything is available that it's needed. Are all those providers and modules available to you so that you can use them? So if I run Terraform in it, and I'm running that with the keyboard shortcut, so that's why you're seeing that I'm executing this. It will initialize provider plugins, check the environment, see if everything is there, said, oh, you are fine. You can just continue working with it, okay? After that comes something that I really miss with ARM templates, something that is really, really cool. The Terraform will tell me what will actually happen when I run Terraform apply, which is a command for deployment. It's kind of what if in PowerShell, if you remember, okay? So when I run Terraform plan, let me do it again with the GUI so that you can see actually what's happening. It will look at my file, look at the state, look at all the resources that are defined in that file, and then tell me, no changes, your infrastructure is up to date. Nothing will happen if you actually run it. The beauty of template and declarative approach with building your infrastructure is that both ARM templates and Terraform templates are idempotent, which means if you run a couple of times the same template, nothing will be destroyed. Nothing will be, there is no harm in it. The whole process will actually first check if the resources are there. If they are there, they will be skipped. If there is a change, then the change will be applied. But all those things that are already there will stay there where it is in the state they had before you actually run it. So in this case, if I run Terraform apply, what will happen is that they will try to apply, and then they will see that everything is okay, and it's like, okay, nothing will change. So you will get this message, apply complete, no resources are added, not changed, not destroyed. Once when you are done with your deployment, with your project, you don't want to use it anymore, destroy it with Terraform. Don't go to a portal or some other tool and delete certain stuff. Why? Because then you will invalidate the Terraform state. This is how that Terraform plan works. They create a file that contains the state of your deployment, and this is how they compare. So if you go outside of a tool and change it, then that's not the same thing that Terraform is aware of, right? So be aware of that. Another tool that I want to mention is Ansible. Now you can use Ansible for infrastructure provisioning, but also for configuration management of your VMs or just ad hoc commands that can run against those machines. One of the best things here with Ansible is that Ansible is agentless. So you don't need to install anything on your targets. Authentication and management of those targets are happening using the SSH keys. And the good thing is also that Microsoft is involved in porting the OpenSSH to Windows as well. You already have it now, but we are waiting for the GA of it. So for the future, even with the PowerShell, the future of remoting is actually SSH, not WinRM. When you work with the Ansible, you work with something called playbooks. You put all your tasks in the playbooks, and you run the playbooks, and you get your infrastructure. So to look at the examples of how to work with the Ansible playbook to create a VM, let me show you here first the Ansible playbook that I have. So you create a task to create you have a task, and then you create a VM. You define a resource group, a name for it, the VM size, a couple of more details. The good thing, again, here, we work with the SSH keys, so we don't need to provide passwords. We don't need to work with secrets that are visible. And then you define the image that you will use. In this case, it's a Ubuntu machine. Once when you have that file, you can then, and in this case, with Ansible, you need to do a couple of pre-steps. You need to create a resource group, and you need to create a network when you want to deploy your virtual machine. One of the things that I really like with the Ansible extension in Visual Studio Code is that if you have a YAML file that contains the task open in your Visual Studio Code, when you right-click on it, you get a nice options here. You can run a playbook in a Docker container. They will pull the container and then run it inside of it. You can run it a local Ansible. You can send the whole file to Cloud Shell and run it in a Cloud Shell, which is already pre-configured for you, or you can run it remotely over SSH. So for us, the best way to do it is to run this playbook in a Cloud Shell. So it will automatically connect to your Cloud Shell, bash, send playbook to your Cloud Shell, and then start deployment. In this case, I'm repeating deployment, so I don't expect any changes to happen. If everything works right, it should just work. So let's wait a little, and then we should get a final report about changes. So as they said, OK, the task is create VM. This is how I'm named the task. And it says, OK, the recap is changed 0, unreachable 0, failed 0. As I said, all those templates are idempotent. You can run them multiple times. Nothing will be destroyed. If I didn't have it already provisioned, we will just go through a couple of those steps to, yeah. OK, so summary for imperative ad hoc cross-platform scripting, use Azure PowerShell and Azure CLI. For deploying using declarative model, we have a couple of choices. ARM templates, Terraform, Ansible, Building Blocks for the whole infrastructure management. For VM configurations, Chef, Puppet, Ansible, DSC. Again, Azure Cloud Shell within Visual Studio Code, the best working environment on Windows 10 and other, or Mac or Linux. Really, this is just amazing. So infrastructure as code plus configuration as code for the win. That's the way how you provision your infrastructure. Thank you very much for your attention. And don't forget to evaluate the session. Thank you again.